Hi everyone, in today's video I will be going over the Unit 3 review for our test. So, on our first problem it says which of the graphs represents the system of inequalities? I'm going to spoil a few details here. First off, if we look at the four graphs, we notice that the lines are all the same. It's the shading that changes. So unfortunately, this is going to come down to the shading. So we need to do two things. First, we need to identify which line goes with which equation. Then we need to figure out how to shade them individually. And then finally, we'll see where the overlap is supposed to be with the two graphs. So I'm going to take the first equation and I'm going to rewrite it in y equals mx plus b form. So if I do that, I have negative 2x plus y is less than or equal to negative 1. I need to get the y by itself, so I'm going to move the 2x over here. I do that by adding it. So that gives me y is less than or equal to 2x minus 1. So let me locate that on the graph. If we start at negative 1, this is a slope of 2 over 1, so we go up to right 1. And I'm going to label these a and b, just to make my life easier. This line here goes with graph A, it's this one, meaning the other equation has to be line B. Since this is multiple choice, well actually I take that back. I do want to solve for this because when you read the shading part, you do have to have it in y equals mx plus b form, so I can't get away with that quite yet. So we have negative x plus 2y is greater than or equal to negative 2. So then to get this y by itself, I first add over the x. 2y is greater than or equal to x minus 2. Lastly, I need to divide off the 2. This is y is less than or greater than or equal to. And then when I divide both of these by 2, remember this is like a 1x, so this would be 1/2 x, and then negative 2 divided by 2 is a negative 1. And then as you can see on that other line, I start at negative 1, I go up 1, right 2. That is this line. So now let's look at the shading. So our first graph here, this would be graph A, line A. This is a less than symbol, meaning we shade down. So we take a ruler here to demonstrate. If this is my line, the up or down comes from the y-axis. So it hits the y-axis at negative 1. So up would be following it up this way, and down would be this way. So we want to shade down. So as you can already see in graph 1, this is shaded up because it's covering the y-axis going up from the line instead of down. Another way to see this, since this is down, if I cut off the part of the graph, this is what's supposed to be shaded if we're looking at just this line. So obviously this graph is shaded up for my line. That is not correct. Next graph. Goodness. Now, this one is shaded down, and I want to tell you, this shaded region we're looking at is the final answer region. So in class, we normally have 3 different regions shaded. We have this line's region, this line, and then where they overlap. This graph has just the overlap. So that means that to get this answer, we did have to shade under this line here. We're just saying that the overlap was this section. So this one's shaded down like it was supposed to, so this could be the answer. This one also shaded down, it's just that other side instead. But this still shades down for our line that we're looking at, line A. And if I go over here, notice there's no shading under the line. It is above the line, so D is not correct. So our final answer will come down to whether the other line is shaded correctly. So we have y is greater than or equal to. Greater than or equal to means we shade up. So line B needs to be shaded up. So line B is this one here. So if I look at that, again, it cuts the y-axis here, meaning it needs to be shaded where the y-axis goes up. So it's going to be, if we cut the graph in half into 2 large pieces, up would be above the line. So if I cut off the bottom, we do have shading here. So that means this is the graph we're looking for. To demonstrate C, why it's not correct, again, we want above our other line. If I cover up the side that's not supposed to be shaded, notice I don't have any shading at all, so this is not correct. So graph 2, answer B, is the correct answer. This is a little complicated to look at, I can understand. So if you want to, you could always separately graph these lines and practice and do your own shading and then see where the overlap happens. That could be a way to do this problem. Get the graph and then just find which one matches yours. That's always an option. Number 2, which is a possible solution to the system of linear inequalities? There's supposed to be a question mark here. So here we have 4 possible points that will work here. Only one of them is correct. The easiest way to solve this is, and really the only way, is to plug these in and see which one works for both equations. So let's start with A. And you may or may not need more paper for this. I might, we'll see. Because I'm definitely running low on space here. So I'm going to test A, -1, -2. So I'm going to plug this into the first equation. We have -3. I'll write it out first. How about that? So my x value is -1 plus my y value is -2 is less than or equal to 1. -3 times -1 is +3 minus 2 is less than or equal to 1. 3 minus 2 is 1. And 1 is less than or equal to itself. So that one worked. So now let's try the second inequality. X minus y is greater than 1. X is -1 minus, that minus is there. The next number is -2 for y is greater than 1. -1 minus -2, that becomes a plus. So this is -1 plus 2, that's +1. Now 1 cannot be greater than itself, so that does not work. So A is not our answer. Option B. I'm going to do the first equation. -3 times our x is -1 plus y is 2 is less than or equal to 1. -3 times -1 is a +3 plus 2 is less than or equal to 1. 3 plus 2 is 5. And 5 is definitely not less than 1. So, B is not our answer. C. -3 times x is 1 plus y is 2 is less than or equal to 1. -3 times 1 is -3 plus 2 is less than or equal to 1. -3 plus 2 is -1. And -1 is less than or equal to 1, so that one worked. So now let's try the other equation. X minus y is greater than 1. So x is 1 minus y is 2 is greater than 1. 1 minus 2 is -1 is greater than 1. -1 is not greater than 1, so that one did not work. Now I'm running out of space. We can pretty confidently assume our answer is D. The one, there is a chance that I did something wrong here, meaning D is actually not the correct answer, so I'm going to still plug it in to show you that it's right. This is good practice, even though I'm running out of space. -3 times 2, which is x, plus y is -1, is less than or equal to 1. -3 times 2 is -6, plus -1, is less than or equal to 1. -6 plus -1 is -7. And that is definitely less than 1, so that works. And then let's try it in the other one. X minus y. So we have 2, be careful here, minus y is -1. This is why we use parentheses, is greater than 1. 2 minus -1. 2 negatives make a plus. Here we get 3 is greater than 1. That worked. D is our answer for sure. Number 3, circle all possible solutions to the system of linear inequalities below. So here are some ordered pairs, and they're just asking, are these solutions yes or no? So I mark out the ones that don't work, and I circle the ones that do work. So just go through the list. I'm going to plot all of them. 2, 4, 2, 4. So the solutions is this region in here. So clearly this is inside of it, so this one works. 0, -2. So we go over 0 and we go down 2. Now this is a maybe. Let's look. This lies on a dashed line. Remember, dashed lines means that these points are not included in the answer. So it's very close but not quite a solution. 0, 2 means we move 0 and we don't move on the x, but we go up 2. Now this one's on the solid line, which means it is a solution. -2, -3. Yeah, it's in there. -7, -10. Nope, it's not even in any shading. -5, 0. So we just go left 5. Absolutely not. It is not in the overlapped shaded area. 0, 0. You betcha. 1, 3. Just barely in there, but it's included. 3, -4.5. Absolutely not. And 6, -4. Nope, right here. Wouldn't matter either way. Neither of those are in there. These are the 5 points. These are the 5 correct answers. The rest do not work. Number 4, solve the system by graphing. State the solution as an ordered pair. So this is the one time we will say you have to solve it this way. So this one's very nice because it's already in y = mx plus b form. So this will be very easy to graph. If you don't have a ruler handy already, you will want one. When you're graphing to get your answer, you want to make sure that your graph is as perfect as possible so that you can get that answer correct. So we have y = 1/2 x plus 4. M, our slope, is 1 over 2. And b is 4. Remember, b is where we begin on the y-axis. So this 4 here is our starting point. Slope is 1 over 2. That means we move up 1, right 2. Now, I like to graph as many points as possible, just so I can more easily find my answer and to keep my line as accurate as possible. And then I'll graph a few going the other way. So remember, you just do backwards directions. So we go down 1, left 2. I'll stop it there. Now let's figure out the other equation in y = mx plus b form so we can graph it. So we need to get the y by itself. First, we move the -4x over here. We need to add it. 3y equals 4x minus 3. Divide by 3 on both sides. Divide fully over here. Y equals, this is 4/3 x minus, this is just 1. Remember, 4/3 as a fraction for a slope is not bad at all because this is still easy to graph. M, our slope, is 4 over 3, and b, where we begin, is -1 on the y-axis. So -1 is our starting point. From there we move up 4, right 3. So since I have double plotted this point, that's going to be my answer. I'm going to plot one more. And actually I can't because I'll go off the graph. So it's alright. I can see where my line's going. Now, even though I already know my answer, I still want to graph these. And I want to get a different pen for this. There we go. There we go. So I can clearly see my answer is this point right here, which is 6, 7. And don't forget to write your final answer as a point. This states what the answer is. So it's not just look at the graph, you see what the answer is. Nope, you have to write it out. Next page, we have one more of those. Solve the system by graphing. State the solution as an ordered pair. This time, neither of our equations are in y equals mx plus b form, so we have to solve both of these for y first before we can even start. So I'm going to do this equation first. 5x minus y equals negative 5. First, we need to get the x over to the right, so I'll move it by subtracting, since this is already positive. Negative y equals negative 5x minus 5. And then I have to have positive y, not negative y. Remember, this is like a negative 1, so we can divide it off. Divide it completely on the right side as well. This is y equals, remember, dividing by negative 1 is just like changing the signs. So this becomes 5x plus 5. So this is my new equation. Y equals 5x plus 5, where m is 5, or 5 over 1, and b, where we begin, is 5 on the y-axis. So 5 is where we start. And we move up 5, right 1. And then I definitely want to do another point backwards. And I'm going to do one more. For the other equation, I have 3x plus 6y equals negative 36. First, I move the 3x over by subtracting it. 6y equals negative 3x minus 36. Last thing I need to do is divide by 6 on both sides. Y equals negative 3 over 6. You can leave it as 3 over 6, or if you notice you can reduce this, you can rewrite this as negative 1/2 x. And then negative 36 divided by 6 is negative 6. So this equation, m is negative 1/2 and b is negative 6. So I begin at negative 6. And then I'm going to go down 1 and right 2, following the slope. Down 1, right 2, down 1, right 2. And I do want to go backwards. So down and right, so now I go up 1, left 2, and notice this is my answer. I'm going to go up 1 more. Up 1, left 2. Now I'm going to graph my 2 lines. Seem to have lost my ruler. Don't know how that's possible. It's a pretty large ruler. There you are. Okay. So again, line them up as best as you can. These look off for some reason. So as you can see, my answer is negative 2, negative 5. And again, you have to state your final answer. Negative 2, negative 5. And that's it. All right, now we're getting into the meat of the study guide, which is the solving systems of equations. This is what we've obviously spent most of our time on in this unit. So I will go ahead and tell you that even though we have pushed this, that we can have 3 different ways to solve this, you really don't want to use graphing here, because if your numbers are larger than 10 and significantly larger than 10, you're not going to be able to see this on a graph. You can also use substitution. However, on problems like pretty much all these except for number 6, when you have numbers attached to all your variables, substitution is not ideal, because then you're going to be intentionally creating fractions. Fractions that you could avoid if you do elimination instead. So unfortunately for these problems, we're really asking you to do elimination. That should be kind of obvious anyway, because all of these are in standard form for both equations. So the obvious choice should be elimination. So that is what I'm going to do on the study guide. If you know how to do another method and you can do it well and still get my answer, feel free to use it, but I would also myself recommend elimination here. Number 6, negative 2x plus y equals negative 5. Negative 3x plus 4y equals 0. So we want to find in a variable we can easily eliminate. With the x's, we have -2 and -3. So my goal would be to make one of these into a 6 and the other one into a -6 for it to cancel. If I look at the y's, I have 1y and 4y. This one's a bit easier to work with because if I had a +4 and a -4, they would cancel. This is already +4, so I'd only have to change the top equation. So that's what I'm going to do. I need a -4 here for these to cancel, so I'm going to multiply this by -4. When you do that, don't forget to fully distribute throughout the equation. So my new equation, -4 times -2 is +8x. -4 times y is -4y. Equals -4 times -5 is +20. So I've got my -4y. I'm not changing the bottom equation, so I'm just going to bring it down. -3x plus 4y equals 0. Now I do the elimination. -4y plus 4y, this cancels. 8x minus 3x is 5x. 20 and 0, if you add those together, you get 20. Lastly, divide by 5 to get x. X is 4. To solve fully, you have to have two answers. You have to have your x and your y. I have my x, let's find our y. Pick an equation to plug this back into, it doesn't matter which one. I'll go with the top one. And go back to the originals. You can plug it into the ones that you've changed, but you're just going to have bigger numbers to worry about. So the smaller, the better. So we're going to start with the -2x plus y equals -5. We're going to put 4 in for the x, so we have -2 times 4 plus y equals -5. Then I solve for y. -2 times 4 is -8 plus y equals -5. Add the 8 over. Y is 3. A good final step is to check your work. You want to make sure that you did all of this math correctly. So, I'm going to plug both those back in. I'm going to call these, I don't have room here, kind of have room here, equation 1 and equation 2 to make things simple. So equation 1, now I'm checking, trying to organize my work as best as possible here. Equation 1 is -2x plus y equals -5. So plugging in, I have -2 times 4 plus y is 3 equals -5. -2 times 4 is -8 plus 3. -8 plus 3 is -5. So that worked. Now let's check the other equation, 2. -3x plus 4y equals 0. -3 times x is 4 plus 4 times y is 3 equals 0. -3 times 4 is -12 plus 4 times 3 is 12 equals 0. -12 plus 12 is 0. So that one also worked. My final answer is the point xy, 4, 3. And that's it. Number 7. Let's look to see what would be easy to eliminate. -4x and 9x. This one would be a bit tricky. I would have to change both numbers. There's no way to change 4 into 9. On top of that, the closest number that they both can multiply to, I'm not thinking very clearly right now, so I would say 36. I feel like there's 36. I would say there's a smaller number, but it's just not coming to me right now. So 36, I would need to turn both of these into a 36. Let's not, if we can avoid that. So let's look at the y's. -5 and +3. Right off the bat, I can get 15. I can change both of these into a 15. And that's the smallest number I can work with those. So let's do that instead. So I've already got a negative and a positive, so I don't want to change any signs. To turn this into 15, I need to multiply by 3. To turn this into 15, I need to multiply by 5. So we're going to do two changes here. Don't forget to multiply through. So I'm going to arrow over to write the new equation. 3 times -4 is -12x. 3 times -5 is -15y. Equals 14 times 3, 42. And then do the same thing over here. Again, multiply through. 5 times 9 is 45x. Plus 5 times 3 is 15. Y. Equals, and I definitely don't know that, negative 48 times 5. Negative 240. Now I can do the elimination. Negative 15y and positive 15y cancel like they should. Negative 12x and 45x. That is going to be 33x equals. Then we have 42 minus 240. Negative 198. Solve for x, so we need to divide by 33. X equals, and this actually comes out very nicely, negative 6. So that's my x value. Reminder, you have to find the y value. You can't just stop there. So again, pick an equation. I'm going to go with the top one since it has smaller numbers in it. Negative 4x minus 5y equals 14. Negative 4 times x is negative 6 minus 5y equals 14. Negative 4 times negative 6 is positive 24 minus 5y equals 14. 2 steps to solve. Subtract 24 over. Negative 5y equals 14 minus 24 is negative 10. Divide by negative 5. Y is 2. And again, last thing you have to do is check. So I'll check equation 1 first. Negative 4 times x is negative 6 minus 5y, so 5 times 2, equals 14. Negative 4 times negative 6 is 24, minus 5 times 2 is 10, equals 14. 24 minus 10 is 14. So that one worked. And then now I want to do that with equation 2. 9x, so 9 times negative 6 plus 3y, 3 times 2, equals negative 48. 9 times negative 6 is negative 54, plus 3 times 2 is 6, equals negative 48. Negative 54 plus 6 is negative 48. And that worked. So my final answer is the point negative 6, 2. X comma y, always. 10x plus 4y equals 13. Negative 4x minus 7y equals 11. So we have some choices here. If we look at the x's, they're already opposites. And the smallest number I can get these both turned into is a 20. If you were thinking 40 off the bat, you can use 40. You're just going to make all your numbers larger from the beginning, but you'll still get the right answer. So, but if we can get this to a smaller number, that would be best. 4 and 7, we would have to make these both into 28s. Not ideal if 20 would work over here. Again, if you looked at this and thought, oh, 40, because 4 times 10, do that. But since I thought of 20, I'm going to use it. Because if I multiply this by 2, this will be 20. And if I multiply this by 5, that would be negative 20, which is what I need. Don't forget to fully distribute. 2 times 10x, that's 20x, plus 2 times 4y is 8y, equals 13 times 2 is 26. 5 times negative 4x is negative 20x. 5 times negative 7y is negative 35y. And then 5 times 11 is 55. If you want to do this a different way, be my guest. You should get my answer if you do it correctly. So feel free to try that on your own. Now we add straight down. 20x and negative 20x cancel. 8y and negative 35y, that should be negative 27y. I'm actually going to check that. Yes. And then 26 and 55, I believe that's 81. Let me check that as well. Yes, 81. And then solve for y. Divide by negative 27. Y equals, I feel like that's 3, or negative 3, but let's check. Yes, negative 3. So there's my y. Don't forget, I'm not done yet. You have to find x and y. Again, pick an equation. It doesn't matter which one. I'm going to go with the bottom equation because it has some smaller numbers. Negative 4x minus 7y equals 11. Negative 4x minus 7 times y is negative 3 is 11. Negative 4x plus 21 equals 11. Solve for x. Subtract 21 on both sides. Negative 4x equals 11 minus 21 is negative 10. Divide by negative 4. X is, this becomes a positive, and then it's 10/4, which I'm going to write, let me actually use a decimal here. 10/4 is a nice decimal. 2.5. There we go. When I plug these answers back in, using a decimal will make my life a lot easier. So now let's check. You definitely want to check the decimals. That doesn't mean you did something wrong, but you definitely want to make sure those are correct. So again, equation 1, equation 2. We'll check equation 1 first. 10x, so 10 times 2.5, plus 4y, 4 times negative 3, equals 13. 10 times 2.5, I believe that's 25. Let me check. Yes. Plus, this is negative 12, so I'll just write, yeah, why not? Plus negative 12 equals 13. So this is like 25 minus 12, that is 13. So that works. Now let's try the other equation. Negative 4x is 2.5 minus 7y, and y is negative 3, almost forgot. Minus 7 times negative 3 equals 11. Negative 4 times 2.5, that's negative 10. And then negative 7 times negative 3 is plus 21 equals 11. Negative 10 plus 21 is 11. That works. My final answer, write it as a point, 2.5, negative 3. I believe I've got 2 more left. Yes. Number 9. 4x plus 6y equals negative 18. Negative 2x minus 3y equals 9. This one is definitely more manageable. And really, you can't go wrong either way. So we have negative 2x and 4x. If we can make this into a negative 4, that would be easy to work with. Just multiply this by 2. Or negative 3y and positive 6y. If I can make this into a negative 6, easy, I'd multiply it by 2. So really, no matter which way I'd go, I'd want to multiply this by 2. So that's what I'm going to do. So this by 2. Distribute that 2 through fully. So I'm going to just bring over the top equation. 4x plus 6y equals negative 18. And then multiply the bottom equation by 2. 2 times negative 2 is negative 4x. 2 times negative 3 is negative 6y equals 2 times 9 is 18. Hopefully some of you can already see what's about to happen. 4x minus 4x cancels. 6y minus 6y cancels. Bring down the equal sign. Since everything canceled, this on the left side is 0. Negative 18 and 18 also cancels, which is 0. 0 equals 0, that is a true statement. So our final answer here is infinitely many solutions. Again, you can write out IMS as your answer. That would also work. But the phrase infinitely many solutions needs to be your answer. One more problem. Number 10. 6x minus 14y equals 5. 3x minus 7y equals 5. Again, numbers are pretty manageable here. We can easily change this 3 into a 6, but it would have to be a negative 6 for these to cancel. Over here, we have negative 7 and negative 14. We can easily change this to negative 14, but we would have to make this a positive 14 instead to make the signs balance. So either way, I'm going to multiply the bottom equation, and we'll make the x's cancel. So I want this to be a negative 6. So let's multiply this by negative 2. Negative 2 times 3 is negative 6. Again, fully distribute. So I'm going to bring my new equations over here. 6x minus 14y equals 5. No change there. Multiplying through, negative 2 times 3 is negative 6x. Negative 2 times negative 7 is a positive 14y equals negative 2 times 5 is negative 10. So let's see what we have here. 6x minus 6x, that cancels, that's 0. Negative 14y and positive 14y, that also cancels. So on the left side of here, we have 0. And then 5 minus 10 is negative 5. Hopefully you look at that and realize that is a false statement. 0 does not equal negative 5. Since this is false, our final answer is no solution. And that's it. All right, how many more problems do we have? Looks like this goes to 14. Now, I know word problems are not our favorite, but good news, you don't have to actually solve these. You just have to set them up. Tickets for the theater are $5 for balcony seats and $10 for seats next to the orchestra. If 600 tickets were sold and the total receipts were $4,750, how many tickets of each type were sold? A says to find the variables. This is where you write, I want x equals the number of seats, something like that. Now, again, I always recommend that you pick letters that make sense for what they are describing, but if you want to use x and y, that's fine. So the first type of seat they mentioned are the balcony seats. So I'm going to use B, and B equals balcony seat. So if I put a 1 in there, I'm talking about 1 balcony seat. I'm talking about 5 balcony seats. Now the other one is seats next to the orchestra. Those are the other type. You can use O. So I'll put orchestra seat. There is a downside to using O. I will get to it, but I'm still going to use it anyway. And this is all you have to do to define the variables. This just is telling me what you mean in your equations. So we're going to set up our 2 equations, and that's it. So the easiest way to start is to work with your totals. Our 2 totals is 600 tickets and $4,750. So here's where I talk about having a money equation. That's this one. So this one is our number of items, in this case, number of tickets. So let's start with this one. This is just the number of tickets that were sold. So we have 2 types of tickets. So if I add the number of balcony tickets and the number of orchestra, then if I add those together, that's going to be the total number of tickets, total number of seats that were sold. So B plus O equals 600. However many balcony tickets and how many orchestra tickets, add them together. They should total be 600 tickets. Now, the second equation is where we care how much each of these seats cost by themselves. So, if I purchase a balcony ticket, it is $5. So, $5 for each balcony seat plus $10 for each orchestra seat. Now, you might be able to see why O is not the best letter to use here. I like to modify it in a way that makes it obvious that this is the O. So one thing we could do, we put a line through it. You could do something to distinguish this, that this is clearly an O and this is a 0. So the cursive O looks like that. So you can maybe do that just to, so you know that, hey, that's an O and not a 0. So I'm going to do that. That's just a personal pet peeve of mine. I won't worry too much about it. I just want to make it obvious, this is not supposed to be 100. It's 10-0. I'm making this way too complicated, and that is it. That's all you have to do. Set up the equations. Don't have to solve. 12, we're going to repeat that process. Gunja bought the meat for Saturday's cookout. A package of hot dogs cost $1.60, and a package of hamburgers cost $5. He bought a total of 8 packages of meat and spent $23. How many packages of hamburger meat did he buy? Again, we don't have to actually answer the question. We just have to set up a system that models this information. So let's do that. Define our variables. So this one you want to be a little bit more creative just because hot dog and hamburger both start with the same letter. I know some people will use D for hot dog because you could just say dogs for short. So I'm going to use D to represent dog, hot dog. And then I'll let H be hamburger. You could have also used B for burger. That would have worked too. Something like that. Just make sure you understand what you're writing. All right, 2 equations. Let's start with our totals. We have a total of 8 and then $23. So again, we have that money equation. And then we have the number of items. This is the number of packs of meat. So again, if you start with the total number of items, this is where you add your variables together. You don't care about how much they cost at that point. So the number of packs of hot dogs plus the number of packs of hamburgers equals 8. Now here's where we care about how much each one cost. So if you bought a package of hot dogs, it cost you $1.60. So you could write 1.60 or 1.6, that's still correct. D plus a pack of hamburgers costs $5, so 5H. And then that should total $23, whatever combination we got of those. And that's it. Number 13, this one's pretty quick to answer. Explain the solution of each given graph. So if you remember, with a system of equations, which is what we've been working on for pretty much this whole study guide, there are 3 possible answer choices, and this is how they look on a graph. If you're not sure about A right off the bat, start with one of the other 2 and then kind of narrow it down from there. So I'll start with B because this is the one that we talked about first and foremost in class. This is what we call one solution. So really the answer to all of these questions is how many solutions do they have? B has 1 solution. Lines cross at a point. It says to explain. So this is the solution, it's 1 solution. The explanation, the lines cross at a point. That's why it's 1 solution. And then I'm sure many of you remember C, they don't cross. When they don't cross, we call that no solution. So that's what this solution is called, and it's called no solution because the lines never cross. So they can't have a solution. A is definitely the most ambiguous of them all. We discussed this a bit. When you graph the 2 lines, they turn out to be a single line, the same line. So this is what we call the infinitely many solutions. Infinite, I'm struggling with it here. Infinitely many solutions. And then again, I know it's not obvious in the picture, but this means that they are the same line. That's why it just looks like 1 line. We have 2 equations, but they turn out to give you the graph of the exact same line. So infinitely many solutions. Number 14. If xy is a solution to the system of equations below, we've got a few questions to answer. What is the value of 2x minus y? What is the value of 3x minus 2y? What is the value of y plus x? So, this seems complicated. This is a multi-step problem, meaning you have to do many things. It's not just a straightforward solution path. First thing you need to do is figure out the solution to the system of equations. So, that's what we've been doing. Not a big deal. We can do that. Then once you get that answer, so this is not the answer, but let me just give you an example to show you where we're going with this. Let's say our answer to this problem is 1, 2. Then what we'll do is we'll plug in for each of these, 1 for x and 2 for y, and get a number, and that's what we're going to put in the blank. That's answering the question. So we actually have some options here. If I were to do this, you could graph this, and I don't recall what the solution is. This one's pretty easy to graph if you want to graph this. The solution will be nice. You'd be able to see it on a graph. But if you don't want to graph this, you could easily do substitution, and I say that lightly. It doesn't really look like substitution. So if I take the first equation, y equals 8 minus 2x, and then I replace this y, because these are both y. So I can replace the y in this equation with the boxed information. So I'm going to replace this y here with the other stuff. 3x minus 7 equals 8x minus 2x. What I'm essentially doing is just setting these two equal to each other because they're both y. So I can just do that. So that's what happened here. Then I solve for x. We've got an x on either side. Move one of them. I usually move the smaller one. Negative 2x, we add it over. 3x and 2x is 5x minus 7 equals 8. Add 7 over. 5x equals 15. Lastly, we just divide by 5. X is 3. And then to get y, pick an equation, plug the x in, get your y. I'm going to do the first one. Y equals 8 minus 2x. Y equals 8 minus 2 times 3. Y equals 8 minus 2 times 3 is 6. 8 minus 6 is 2. Y is 2. And then, I know it's annoying, but let's check. Let's just make sure we are correct. Equation 1. Y equals, so this is 1 and 2, just to clarify. Y equals 8 minus 2x. So y is 2. Equals 8 minus 2 times x is 3. 2 equals 8 minus 2 times 3 is 6. 8 minus 6 is 2. That worked. Now let's check the other one for good measure. 2. Y equals 3x minus 7. Y is 2. Equals 3 times x is 3 minus 7. 3 times 3 is 9. 9 minus 7 is 2. That worked. So my answer is correct. So my answer at this point in time is 3, 2. But that's not the answer to the question. We have 3 questions for being asked here. These are going to be my answers. So the first thing I want to know is what is 2x minus y? And since I'm already using 1 and 2, I'll just call these A, B, C. A. 2x minus y. So 2 times x is 3. Minus y is 2. 2 times 3 is 6. Minus 2 is 4. A is 4. B. 3x minus 2y. 3 times x is 3, minus 2 times 2 is 4. 3 times 3 is 9, minus 4. 9 minus 4 is 5. B is 5. And then C, I'm going to do at the bottom here, y plus x. This one won't take much room at all. Y plus x, y is 2, plus x is 3. And 2 plus 3 is 5. So that's also 5. So my final answer, the answer to the actual question is 4, 5, 5, all 3 of those to those individual questions. That is all for this study guide. I hope that it was helpful. I will warn you, I think I kind of clarified this quite a bit earlier. It's really important you know how to use elimination. That's going to be the most useful method on this test for solutions that are not whole numbers or that are too large to graph. Graphing's not going to be great. And then substitution might give you some pretty ugly numbers. You could still get through the problems with substitution, but ultimately elimination seems to be the best way to go between looking at the study guide and also by looking at your test. I can tell you that for sure. So just kind of an FYI, make sure you're able to do these problems on your own. If you have any additional questions, feel free to come see me in person or feel free to email me. Otherwise, I hope you have a wonderful day. Bye!